by falling film and by standard, what we're referencing there is a flooded versus a falling film, or in some cases, hybrid falling films, depending on the setup. So let's kind of identify a difference in what these are at the moment. So looking at it from the water box side or the in-bell side, okay, so these are to be two separate evaporators. All right, we got our tubes. Okay, this one on the left is going to be what a flooded design. This over here would be a falling film, and we would have a set of baffles here with a distribution rail, and then our refrigerant coming in would come in as high pressure up here and tap in. Okay, and then our suction gas would still come out the side up into our compressor. Okay, this would be our suction vapor. So a falling film, what is happening is right here we're hitting our metering device, and then we're flashing off into our distribution rail. So we come into the distribution rail here in the top of the evaporator, and it sprays a mist of the refrigerant over all the tubes in here, and that mist rains down over the tubes. So the refrigerant's on the shell side, water is on the tube side. And then by the time we're getting down here to the bottom of our tubes, we would expect that the vast majority of that refrigerant to have evaporated off or boiled off. And we would just have maybe minor little pockets of liquid down here at most, typically. Now, this is with a true hardcore falling film, or something like, I would give an RTHD as an example of this, or a YVAA. Those would be examples of a more traditional falling film where there is some liquid refrigerant that does stack on the bottom of those, and I think those actually do have some tubes that do get down and touch on that liquid refrigerant. So it's not that there's no liquid refrigerant in the bottom of our applications where we see this on the chiller side, but it's very, very little. And the YVAA, has a side glass over here where you can see through. The RTHDs have their liquid level control sensor, which this is what runs the metering valves. So this would be a falling film, and yeah, all this kind of boils off and up into the compressor suction. Now, a flooded, on the other hand, we're going to have our liquid refrigerant come in to the bottom of the barrel. So this is one way to tell them apart. So this will be our metering device. This is where we flash off, and we're going to feed into the bottom. Now, there is still typically a distribution rail here at the bottom of the evaporator, and to make sure we distribute across the full length of it. So we do have some management there, but we're just injecting that saturated liquid up into the evaporator from the bottom side, and our goal here is we want to maintain a liquid level up to the top of our evaporator tubes. And so most of the time there'll be a screen mesh right above the tubes and where the liquid level will be. So we want the liquid level between the top of the tubes and that screen mesh. And that screen mesh helps make sure we don't have any liquid droplets make it up into the compressor. It also helps kind of act as like a distribution on the pull of the suction. So like right here, we've got these baffles that pull the refrigerant around the tubes and give it space to kind of flow without having this mist accidentally pull into the compressor suction. So that's where this baffling plates, that's why those are there. Over here, using that eliminator, which is just a mesh screen, we can we're doing the same basic effect and function, just in a different way. Yeah, our compressor suction then comes off the top, refrigerant boils off, comes up into the compressor. So there's the core difference between these two styles of evaporators. Now, in terms of the core question, which was what types of chillers are likely to have falling film versus the standard kind, it's going to come back to newer machines are going to be favoring this falling film design or hybrid falling film design, which, to very briefly get into, essentially with a hybrid falling film, we run a higher liquid level, and I guess I should draw it. So we still have the upper section of tubes like this. We still have the distribution rail and the baffling. But then down here at the bottom, we have an intentional set of tubes that are going to stay submerged. Okay, so it's quite literally these two kind of combined into one. And then we're going to try to maintain liquid level right there in the middle. And then, a YK would be an example of this. YKs will use a hybrid, and this is something I I was taught to refer to this as a hybrid, even though I'm talking to factory guys, they don't necessarily think of it that way. But this is a hybrid style of falling film because we are still intentionally submerging some tubes in a way that we're not necessarily, it's not as intentional here. I'm not saying tubes don't get submerged at all at the very bottom, but it's not the same thing. This, you might have a couple of inches of liquid level. This, you'll have maybe a couple of feet in some cases, depending on the scale and the size of the machine, and all that's intentional and part of the design. These will also still have the liquid line inject into the top, coming into a distribution rail, separate from these, or from the falling or a flooded design. So we're seeing these two take a lot of precedence, especially on, I would say, smaller machines. So we're talking about screw machines. I see the falling film, a more true falling film design implemented a lot more and a lot heavier. And then on some of the larger ones, say a YK would be the example I'm using here. This is where I'm seeing them implement kind of this hybrid design. Now, they still refer to this as just a falling film. They don't use the hybrid term. That's something I use to differentiate these because they are different in that way. If you look at it from a very, say, purist perspective, I guess that's how I would say I'm kind of coming at this is hard definition. I wouldn't define this as a true falling film. Okay, that's my sticking point. I'm going with there. Anyway, your screw machines, RTHD, like we're talking, or a YVAA, that is where we're seeing these implemented. And then on your, say, larger, specifically centrifugal type machines, we're seeing this implemented. So the flooded specifically gets used on both sides of that, whether it be screw or centrifugal. Your newer, more modern, and higher efficiency designs are trying to go with a falling film, either of these style, for a couple of reasons. One, in terms of efficiency, these are very close. They're close enough to a flooded's efficiency to still be practical and keep our size down. So that's one of the key benefits to chillers is we can fit a lot of cooling capacity into a smaller package. It's not as big of a machine. And so as compared to, say, what it would require if we had RTUs and split systems, like things of that scale compared to this is where we really shine, is we can fit a whole lot of cooling into a fairly small total space comparatively. So what's great about flooded is we maximize how much heat process we can have in such a small confined space. The problem with flooded is it takes a huge amount of refrigerant to get all those tubes fully submerged. And then as these machines scale into larger sizes, that problem only gets much worse. Like, it takes a massive amount of refrigerant comparatively. So one of these, on the other hand, we're not trying to hold a huge volume of liquid refrigerant in the evaporator. We're just at most a small volume to a moderate volume. So that greatly reduces how much total charge that machine requires. But efficiency wise, we can look at our approach value as a metric of that efficiency. These run the same approach values and they're designed to run the same. Now, you may see that a falling film evaporator may be slightly larger, if you can even tell the difference in terms of physical size. And I would say that I would argue that comes back to, it's not the exact same level of heat transfer as a flooded in terms of we will need more surface area because while we're raining liquid refrigerant over the tubes, they're not literally sitting in liquid refrigerant. I think it's one reason why York really likes this, hybrid design so much, is because it does kind of incorporate both the best of both worlds. Because that's so much less refrigerant, but we still have the same efficiency, that reduces the cost of this a lot, but we keep a very similar size and profile, and we still maintain our efficiency metrics that we're trying to go for. Like, we're not losing efficiency by coming over here, and we're very marginally affecting the total size the machine has to be. So that's where the falling film is getting implemented. Now, we're not done with flooded. Done on Bush machines, the AVX series, they're still shipping with flooded evaporators. The metering device feeds into the bottom. They're fully flooded, the tubes, and then it comes back out the top. But they're controlling based off of liquid level anyway. Without getting into crazy details, like, these are still going into brand new machines. So let's just keep that in mind. But the benefits of moving to a falling film design is that lower total refrigerant required and maintaining the efficiency of it. But we get into, I don't know, I'm sure there's things from an engineering perspective, like if we were mechanical engineers, there's probably a lot more reasons as to why one, not the other. And in terms of cost, R&D and development, proven systems, like, this is a newer, now it's been around for a while, don't get me wrong, but this is a newer style of evaporator. I'm sure there's all kinds of patent disputes around this stuff anyway, because these have become the preferred by manufacturers. So I'm sure in some cases, we still see these being shipped with flooded just due to patent infringement issues to begin with. They don't want to get sued by somebody because of, they tried to copy what York did in the wrong way, and then York says, hey, that's mine, and you get into the whole tiffs there. The YK, their YMC squared, their YZ line, all of those use the hybrid falling film on newer machines, not your older ones. So you'll still have plenty of these flooded out in the field. So if that line is coming into the bottom of the evaporator, it is a flooded design, and you'll notice that the sight glasses are up higher on those machines than if you've come across one that has more of a flooded or a falling film design. They'll be a little bit lower down on the actual outer shell to be able to look in there. That is further just shows how we're changing the liquid level that's actually being held in that machine. So I don't know if that's something you may notice out in the field, is a difference that you'll see between the two, is kind of even where they're placing the sight glasses to begin with.